Hello and welcome back to the 10-minute Bitcoin show. Gonna have you guys out here before the next block. Today we need to talk about software versioning, apparently. This was something that I've seen people confused about recently, so I thought it'd be worth talking through. And also, yeah, if there's any other topics that you guys would like for me to talk about on this show, let me know. I'm happy to talk about pretty much anything. I think enough people talk about like Bitcoin treasury companies that I probably don't need to cover that, but I'd like to mainly do like technical topics. But if there's anything specific you want me to cover, shoot me a DM or comment on the videos and I'll try to get to it if I think it's interesting. No promises. So there's been a lot of people that have been confused why. Well, there's certainly been like a narrative, like this guy that I responded to here, who, you know, I don't know anything about him, but he was confused because Core is pushing out updates to the 28 branch and the 29 branch. And some people were suggesting that this is because the 30 branch is so controversial that Core was like somehow backtracking and pushing fixes to older branches instead because changing the default value of a config line was so controversial and damaging. But really this isn't true at all. So the way that software life cycles work is that you tend to make changes in different branches. So you'll have like if you look at this image here, you can see that there are different numbers separated by decimal points, and those decimal points basically represent I guess you could call it like the seriousness of the change, or seriousness probably isn't even a good word, like the scope of the change. So major version changes are going to be the big number, the first number. And in the case of Bitcoin, like this isn't necessarily a strict rule with every project. Like not every project follows like strict objective rules here. It's kind of up to the individual project on how they want to manage their versioning. Like you can make whatever release you want, whatever version number you want. There's no hard rules, but generally speaking, this is how it works. So like when you see like version 29.3 of Bitcoin get pushed, and that might be confusing because version 30 came out. What you can reasonably conclude is that there was some major change that happened between 29 and 30 that is I don't want to not backwards compatible, but not in the sense where we're thinking about like consensus changes and backwards compatibility with nodes on the network or anything like that. It's more so to do with like software that developers will hook into in that software implementation. So if let's say for example, like I wanted to access some command in the Bitcoin CLI. Let's say I'm working on a software project and I am building on top of a certain version of Bitcoin Core, and my software hooks into some command in the Bitcoin CLI. If that's called like an API, it's basically like an interface for me to access code within the Bitcoin Core code and use it like in my own app. I'm like hooking into Bitcoin Core through that API. If they are making changes to that API and then deploying those changes, that's probably going to be like a major version change, because if I then update my core backend that my software is bolted on top of without understanding all of the changes to the API, then when my software goes in and tries to hook into that CLI or whatever API I'm touching to try to access that code, it might break because I have certain assumptions in my code that's like bolted on top of Core, where maybe like the name of the function changes, or maybe the parameters of the function change, or like certain data structures are tweaked slightly, and you have different considerations that you need to take account for. So the way that this tends to work is that software branches tend to have different life cycles where they will continue to push things like bug fixes to older branches for the people who are not yet ready to upgrade to the new major version change because they haven't revised whatever software assumptions they have bolted on top of that base system. But those people, even though they might not be ready for the major version update, they're still going to want the latest bug fixes. And this is particularly important because like Bitcoin Core, for example, is the back end of pretty much any security critical application with regards to Bitcoin. Like anybody doing serious Bitcoin custody is going to be using secure software. They're not going to just be running like random crap, or they're going to be rolling their own stuff in house in conjunction with that, like bolting it on top, like I said. And in which case, updating core features of whatever your suite is that's securing millions or billions of dollars is going to be really important and need to be done really conservatively. So if you're not ready for those major API changes, if you're not ready to support those for whatever reason, but you still want those bug fixes, that's why they're going to be pushing bug fixes. That's why you're still seeing releases come out for like branch 29 and branch 28. Is not because 30 is controversial and it's being abandoned or anything like that. This is just a normal part of a typical software lifecycle for how the software supports all of its users across the life cycle. And eventually you see the older branches like 27, it reaches its end of life. And the only thing that it means when that branch reaches its end of life, it doesn't mean that you can't run it anymore. You could still download it and run it. And it doesn't even mean it's not going to work anymore. It just means that that branch of the code, that major version, is not going to get any more patches. And if you want like new patches and bug fixes, you have to switch to a branch of the software that is still within the current life cycle, meaning that it's still receiving updates and that it hasn't basically been archived, so to speak. So hopefully that clears that up. I've seen a lot of people that seem really confused about that. And the problem with this show is that I have 3 minutes left. And what do I talk about now? I'm going to read this tweet that I don't think I'll have enough time to get through this, but I'm going to read this tweet that I had the other day. This is just some thoughts, and I don't have this isn't 100%. But I'm just going to read it. A Bitcoin node is a wallet backend, not a magical talisman that helps the network. A Bitcoin node is a tool made for the user who runs the software. Its impact on the network is only tertiary. Let me explain. When I say that a Bitcoin node is a backend, what I mean is that it is the portal through which one can access the Bitcoin network and receive information about the state of the Bitcoin network. A node contains a database of all the blocks in the Bitcoin blockchain from 2009 all the way up until today. When people talk about the Bitcoin ledger, they are referring to this database. A node also contains a database of all the unspent transaction outputs currently in the ledger, aka the UTXO set. A node also contains a list of unconfirmed transactions that are currently bidding to get entered into the next Bitcoin block, aka the mempool. Running your own Bitcoin wallet backend ensures that you are obtaining access to the network and information about the network in a trust-minimized fashion, rather than relying on trusted intermediaries to provide that information to you. A common misconception is that your Bitcoin node somehow forces others on the Bitcoin network to act a certain way or follow certain rules. However, this is a gross oversimplification. A Bitcoin node enforces rules locally, or in other words, only for the user running the software. Technical difficulties there. A Bitcoin node enforces rules locally, or in other words, only for the user running the software. This is precisely why a node is so important. A distributed consensus is a series of peers with wallet backends, all locally enforcing the same rules and thus in agreement on what is the current state of the ledger. A Bitcoin node establishes peer connection with other nodes broadcasting data on the network, receives from them new blocks or unconfirmed transactions, and decides whether or not it considers that information valid. A wallet backend is of crucial importance when it comes to interacting with Bitcoin in a trust-minimized fashion because it represents essentially all that Bitcoin is. What is your wallet balance? What addresses belong to your wallet? What fees do you want to pay? Who do you want to send your transaction to? I'm out of time. If you want to read this, I'll put it in the show notes. Just some thoughts. I'd like to get some more feedback on this actually, because I'm trying to flesh these ideas out in my mind. Thanks for watching, guys.